Okay, so in this example we have a little simple system here, and we're asked to find the value of C which corresponds to critical damping, and we're given numerical values for K and M to do this. So as with all these problems, we can start by simply drawing a free body diagram of the system, and in this case it turns out to be a fairly simple one. In this case, if x is a downward positive quantity, we know we'll have m times x double dot going down. And if x is downward, we know we'll have a spring force kx as well as a dashpot force cx dot acting up. And so if I go ahead and sum forces in the x direction, doing downward positive in this case, and by the way, of course, I should note that I also have the weight up here, it's important not to forget that, then I'll have sum forces in the x is equal to m times x double dot. And if I go ahead and plug this together, what am I going to have? Well, I'll have minus kx minus cx dot plus mg is equal to m times x double dot. I can go ahead and rewrite this into standard form, and that'll give me m times x double dot plus c times x dot plus k times x is equal to mg. Now at this juncture I want to find a value of C that corresponds to critical damping. Critical damping, of course, is a damping ratio statement, namely where the damping ratio is equal to 1. And so in this regard, what I want to do is I want to mass normalize this equation of motion. So if I divide through by mass, I'll have x double dot plus c over m times x dot plus k over m times x is going to equal, in this case, simply g. Now I should note at this juncture that by definition, the parameter c over m will equal 2 times zeta times omega n, and that by definition, omega n squared will equal k over m. In this case, I want critical damping, and so I'm going to set zeta to be 1. If I do that, the first equation gives me c over m is equal to 2 times omega n, which from our second expression is the square root of k over m. I can go ahead and solve this for c now and find that c is going to equal 2 times m times the square root of k divided by m. And that will be my answer for what I need to have for critical damping. You can plug in numerical values for k and m in this juncture if you want a number, but this will be a good generic expression for us to use. Best of luck as you work through this.